Alright, so let us begin. So hi and welcome to the Godot Introductory Workshop conducted for the Global Game Jam 2022. This is presented by the NUS Game Development Group. I am Brendan. I am from the NUS GDG, and we'll be presenting on you about the basics of Godot, and we'll try to show you what you can do with Godot as well as the basic UI. We will try to do one tutorial to show you what kind of game you can make with Godot, as well as a basic rundown of all the things that we have. The disclaimer for today is that please do ensure that you've done the data protection policy, personal data protection form to ensure that you know the terms and conditions for joining the workshop today. Nonetheless, thank you for joining today's workshop. Another disclaimer is that despite us saying that we will be ending at 9:30, we will probably be expected to end at around perhaps 10 o'clock. Nonetheless, we will still be here past 10 to answer any more further burning casual questions that you might have. Okay, so with that, you're also expected that 3 things were downloaded before coming to the workshop. One of them is, of course, the Godot. So later on, we will still show you the download link if you have not managed to download it yet. We'll also be downloading the assets that was needed for the game tutorial later on. So if you have not gotten it now, you may refer to the email that was sent to you in order to download it right now. Alright, with that, let us begin. Oh yeah, one more thing. If you have any questions, do voice them out via the Zoom chat, or you may also private message any of our helpers. They are labeled with the tag in the front. So with that, you can they will answer any of your questions, and they will help you understand the Godot engine much better. Okay, with that, we will now begin. So let us see what is Godot in the first place. Right, so this was the agenda that I was talking about. Today we'll try to make the general rundown. We'll try to dodge the creeps, which is the first game you might be creating in Godot. Now, of course, this workshop is intended for beginners. Therefore, it will be really a bit, surface level. So we won't go into too many things. Also, we'll talk about how the Godot engine runs. All right, so what is Godot? So you might heard of Unity, which is probably the most popular game engine, and also Unreal Engine. Now, Godot, much like those other two, are also game engines. So, yeah. So therefore, you'll see that as a game engine, it allows you to create many games. It also has many other UI functions built into it to allow you to make the game process much easier. For example, it can help you integrate animations and different images to help you create sprites that is needed for the game. You might have also heard of other types of game engines, such as Game Maker and RPG Maker. However, those are paid, and you need to pay in order to use those game engines. And despite Unreal and Unity being free game engines, they are still proprietary, and some may even require you to have a royalty type of plan, such that if you are earning any revenue with the game engine, you will go to the original creators. However, this is where Godot stands out. So Godot is a free and open source software. In other words, FOSS. So you might have heard of FOSS software. It is the ones behind. FOSS is the software that is used and is free and open source, much like VLC, Blender, and all those type of open source software that is very popular to use. So Godot means that being free and open source means that Godot will not take a single cent from you, and the game is completely yours. It is completely free. And you might see that when you download it and install it, you'll be like, wow, I get all these features for free. No strings attached. And I don't even need an account to sacrifice my personal information to create games. So that's what makes Godot kind of very appealing to some people. Now, to most people, what makes Godot more appealing is the fact that Godot can be really fast in creating 2D assets, and mainly its strength is in 2D games. Nonetheless, Godot does have 3D capabilities that we will show you later on. Alright? Okay. So Godot allows you to create 2D and 3D games. It uses a node-based architecture that we will show you later on. It also accepts multiple languages. So You know that Unreal Engine uses C++, Unity uses C#. Godot has many different type of languages that you can accept, such as C++ using native script, C# with a little bit of support since it's in early stages, Visual Script, which is really useful for beginners and also for for primary school children, just in case they need help with learning. However, the one we'll be using today and for almost the entire community will be using is something called GDScript. Right? It is a Python dialect and it is in fact only specific to Godot. So in a way, you're kind of learning an entirely new language with a little bit of different syntax, but very much like Python. Godot also has very extensive community support with many free assets being given out on the community, and also a lot of documentation online and tutorials online for you to help you get started with your Godot journey. Now you can find out more in the link below in godot.org. So if you have no idea what Godot is, you may refer to this website and see what kind of games that people have made using Godot and what kind of features it might have. Right? So moving on, we expect that you have installed Godot. So if you have not, our helpers will send you the link and then you can download Godot. Now you will notice that Godot installs really quickly compared to Unreal Engine and Unity. And that's because Godot is completely self-contained and all these tools that you need is right in that perhaps 500 megabyte file. Yeah, around there. And with that, you can just get started with game design straight from using this small little process. There's no need to install it onto your C drive, your program files, none of that. It's all contained within the file itself. Alright, so with that, let's see. With that, let's see what Godot can do. So with that, I will try to show you the basic rundown. Okay, so once you have installed Godot, you probably notice it is in your downloads folder. Afterwards, you can bring it out, run it, and then you will have this Godot version 3.4 stable Windows version, for example. Now, once you run it, you'll get this project window. Now, mine is different from yours because I ran it before. But if you are running it for the first time, Godot will prompt you with some different questions. Now, just go through with it. You'll notice that you will say that perhaps your working folder will be in the documents folder. So you can keep it there, but if you prefer, you can keep it in your desktop. So what you notice is that Godot does, in fact, keep its project files in your documents folder, as it should be. And you can create a new folder called Godot to get started on your game development journey by keeping all your Godot asset files there. So all these are the projects I've done so far. I have not had an extensive period of time with Godot, but that is the number of files that you can keep here. So let me show you what Godot can do. So if you want to start a new project, and we recommend that you follow through with me on this. So to get started with Godot, once you're on this window, and after you've gone through the first startup processes, you want to create a new project. Alright, so you can create a new project here. Click on this, and if you need further zoom in, I can help you zoom in as well. Alright, so what you notice is that you want to write a project name. So I can call this the physics showcase, for example. Name it anything you want. Okay, so I want to show you the physics of this game. Alright, and currently Godot is complaining and showing this X. There is nothing here. What I can do is that once you have determined the project name, you can create a folder. Now, hold on. Let me redirect myself. So I have a Godot folder. You might want to create one yourself. And what I want to do is instead move up. This is my documents folder. I want to create it in my Godot folder. So I'll select Godot folder. And then I'll create the project folder right here. Alright, so there's renderers. We'll just use the open GL ES 3.0. That's a brief description of that right there. Right? So after you're done with that, you want to create an edit. Okay, hope you're catching up with us so far, right? So once you create an edit, this is where the magic happens. And you notice that you'll be brought to this very nice 3D viewport. So this is the Godot interface. Alright, now we may not be dealing much with the 3D environment. So you can move around WASD, you can move the camera and right click and all that stuff. But we won't be focusing too much on the 3D. Let me showcase the UI for Godot. On the top, you'll notice that there are something called viewports. So there's a 2D viewport, And what we show here is the 3D viewport. So we'll mostly be working with 2D because 2D is definitely much easier than 3D. And we also have something called script. So here is where the scripting happens, where you code your code, right? So all this stuff is right here. You also have the asset library, in which you can basically find mods, like, you can find modifications, like, Minecraft mods, that kind of stuff. Yeah, you can find modifications that you can make to Godot. People on the internet make this, and it's free of charge for you to use anytime you want. So it's kind of like the Unity asset store, right? But instead of just assets, it also provides some other tools for you to use as well. All right. So next, we want to go back to the 2D viewport. So get used to changing the viewport. Now, the ones that we'll be mainly using are the 2D and the script viewport. All right. What you notice next is on the left side, there's something called a node. So this was a node architecture that we were talking about just now. So here would be the node architecture. And what you notice is that they will try to specify to you what kind of nodes they want to create. So of course, since we're in the 2D scene, we want to create a 2D node, right? So with our 2D node, it is simply a circle. It doesn't have anything. Okay, I will showcase you the rest of the UI. So here we have the files. Now the file structure is very simple. It's much like what you see in your other operating systems. So it uses something we call the root. So this res kind of stands for root. So the root of your project folder, which is kind of stored in where you created your projects folder, is where it will store everything. By default, Godot will give you an icon for you to put in if you want. Okay, next, so this is where all your assets will be going into. Next, on the right, you notice that if you click on the Node 2D, you get something called an inspector panel. So the inspector panel is also a tab of the node panel. Now the inspector panel here allows you to change some of the settings of the node. Now we will see later what kind of users we can have for this, but it basically gives you all the surface settings that you can do to modify and configure the node. All right, we'll show you this later. Underneath it, there's also a node which talks about signals. So if you are used to JavaScript or any other languages, you will notice that these are kind of just like events. So these are your events. For example, the events to get ready, like on ready, that kind of events. And there's also grouping, so you can group your nodes together. So what is a node? Okay, so a node is basically just an element of your game, is to put it quite simply. So in our most surface level, a node will be called the node. In other words, the name. So we can rename this, we can double click. We also can press F2, in the case, and then afterwards you can rename the game. So under this game, this is your 2D scene. Everything that happens, like for example, Mario jumping right here, that happens in the 2D scene, the game. So what you want to do next is that you want to right click. Okay, so you can see the green circle. Whenever there's a green circle, it means that I'm right clicking. You also can press this button right here, the F1, the add a child node. So every other game element, for example, your character, the background, all of it is an element of the game scene. So what you want to do is that you want to create a child. Child means that the element is the child of the scene. So let's add a child node. What you notice here is that all the possible nodes that Godot accepts is in here. So with all the possible assets that we have in here, you can actually choose what kind of nodes you want. So for example, let's try, I want to show you what the Godot physics engine can do on surface level. So let's add something called a rigid body 2D, RIGID. Okay, so rigid body 2D. So what does this do? You can hover and then it can show you what the basic description of each of these nodes do. Okay, so a rigid body is a node that's under the physics body 2D. So what it does, what does it do? It's a body that is controlled by the 2D physics engine. That means that unlike a player, which you want to manually control, a rigid body will be affected by the gravity. So then you can imagine that this is very useful for creating bullets, arrows, this kind of stuff that is affected by gravity. So let's double click on this. And now you notice that there's another node in the node tree. So this node body, let's call this a ball. All right, so this ball is a child of the game. What you notice is that Godot is completing using this yellow symbol. It's saying that there's no shape. So let's add a shape. Okay, in order to give the ball a shape, you want to create a child of the ball. Okay, so to give it a shape, the shape must be a child of the ball. So you can type shape, or you can type collision, and you want to select something called a collision shape to be. This gives the object or the node its physics properties. In other words, its collision shape. You can specify the shape to be a circle, to be a square, anything that is within the 2D boundaries. So let's double click on this again. And now you get a collision shape. Then you notice that Godot is complaining again. Okay, so what is this talking about? It's saying that there's no shape. Alright, so this is when I bring you to the inspector panel. So on the right side, you notice that as I select different nodes, it has different settings coming up. For example, what I said about the rigid body being a physics affected object. You can see here there are some physics properties such as mass, weight, gravity, and all those things that affect the forces as well as the angular forces affecting the body. So of course you can play around with these, but for now, let's go back to our shape. Our shape here, our collision shape here is saying that there's no shape. See, it's empty. So what you must do is that you go here and then you must select the empty. Okay, now it's a drop-down panel. There are multiple shapes that you can choose. Let's select a circle. Okay, a circle is very simple for us to show the physics. Okay, so now you notice that there is a circle. If you zoom in really closely to the origin, you notice that down you do have a circle. Alright. So this circle is representing the ball's shape. So now what you want to do is that you want to give the ball some kind of what's it called? Image in order to give it its looks. So to give it its looks, what you notice under the nodes panel, if you Control A once more, okay, Control A, you should add a sprite. Now there's two types of sprites, an animated sprite and a normal sprite. We'll use a static sprite, something that doesn't have any moving frames. So let's add a normal sprite, and then we'll just leave it like that. Currently, the sprite does not have any texture, but we can change that by dragging anything from our file system right here. For all our file systems has the assets. Imagine that you have the assets right here. What you want to do is that you want to drag this icon and drag it to the texture. Okay, drag the icon and drag it over to the empty texture. Now, the sprite will not be empty. You also notice that our collision shape is now hidden. That's because in Godot, the scene tree, the lower you are on the scene tree, the more surface level you are. So now if I stop, I drag and drop, and it will show a line here to show that I'm going to go below the sprite. Right? So now I have a shape of a circle on a square object. Now it doesn't really make much sense. But now, what also doesn't make sense is that the circle is way too small. So what we can do is that we can minimize the shape of this. By dragging the sprite, you can change its dimensions. By holding shift, you can lock the aspect ratio and prevent it from shifting any further. And to prevent it from moving further away from the origin, so you notice the origin right there, right here, is actually moving along. You can hold Alt to fix it to the origin. So now you have fixed it to the origin, it will be squared like that. You can hold shift along with it, and then now it will lock the aspect ratio as well. Now we have a suitably sized object compound. Alright? Now a very handy trick, for example, you want to move this ball away, but then now you're moving the sprite, and then you want to move the circle away. To help you move this entire object all together, you can do this, whereby you drag and drop and select everything. But what you notice is that the game is selected as well. So what you want to do is that you want to select this ball only, right? Okay, come here. There's this little button with two gray squares up here. I can't see because my Zoom screen is blocking. So it's this little button. This little button right here. This thing will allow you to shift the object while making sure that all the children are along with it. So now I just select this, everything will move along. Okay, so now I'll move it along to the bottom right. So if you've learned in maths, this is like a graph. Our fourth quadrant will be where our game scene is. Now, what is the game scene? You can actually see. Now remember, you can press space and you can drag to pan around the canvas. This is our game scene. So along the blue boundaries, that's where our game would end. Okay, next up, we want to show you the physics, right? So I can show you the ball dropping. Okay, so what you want to do next is you want to save your scene. All right, to save your scene, you can press Ctrl S, or you can just go to the scene and save. So let's just call this game, and PSCN is the file extension used by Godot to specify a scene. Let's click on save, and now you notice that the scene has been saved. Okay, in order to play your game, okay, what we expect is that this ball will fall down straight downwards because there's nothing affecting it. It is a rigid body and therefore it's affected by gravity. To play this game, what you want to do, instead of pressing this button, which is to play the entire game, you want to press this button, okay, the play scene. The play scene is going to play this scene only. Now, in an actual game, in a very big game, you have multiple scenes, one for the character, one for the ball. So what you want to do to test each individual element of your game properly is to press F6, and then you can press this play button next to a clipper. Okay. Now you notice that a new window has popped up, and it's just shown a ball falling. Very interesting. Now, if you play the game, you can show that the game is in fact working, and that the ball is affected by gravity. So that's how you play your first scene. Now let's make things a little bit more interesting. We can even add some more elements. So I'll go through a little quicker. Now what we want to do is we want to make the ball slide off a little bit of a ramp. Okay, to do so, we want that ramp to not be affected by gravity. The opposite for a rigid body would be something called a static body. So your static body is, you can type here to search for static, and now you want to add a static body 2D. Right? It's complaining that it doesn't have any shape. So let's give it a shape once more. And now let's make this a rectangle. Okay, so a new rectangle shape. Let's go through this a little bit quicker. And now we'll try to make this shape a little long rectangle. Once more, I will make sure that this object does not have selectable children. So you can see this gray double square. It's because of this one right here. Okay. And now we can just shift the entire thing downwards. Okay, so we want this ball to fall off a ramp and perhaps slide down. So now that it has a collision shape, you'll expect that this collision shape will not be affected by the other collision shape. Will be affected by the collision shape. So it will hit this ball and hit this invisible wall and won't do anything. So let's see. Okay. Wow, you notice that it stopped. Okay, it didn't do anything. You can even do more interesting things, such as making it such that this thing is rotated a little bit. So you can press this, you can press E, or you can press this little button on your toolbar to rotate the object. So you can rotate it. And if you want it to snap, much like always, is other open source software, you want to press Control to move it in 45-degree angles. So let's do it like this. I rotated it, and now I want to go back to my select mode. You also can change the specific angle of the object by going to the transform. So what you notice is that the rotation degrees is in fact 15 degrees. And the position is offset from the origin by these coordinates. So with this, let's play. And what you notice is that the ball is in fact rolling. And in fact, the sprite also rolls together with it. And once it's reached the end of the ramp, it will fall. Okay. So that's it for the game. Alright, so that's it for my rundown. So this will basically show you what you can do with the Godot engine. I hope that everyone is clear on what can be done with the Godot engine. Alright. Okay, you may ask any questions at any time, at any point of time, and our helpers will help you with it. So if anyone needs any more catching up, you can do so. I'll spend about 5 minutes answering any questions. Okay, so to rotate, there are multiple ways to do it. You can go to the inspector panel, whereby your object's rotation is specified here in the transform. Okay, right here. Okay, yeah, rotation. But you can also 3D rotate by using the toolbars on top. So there's a bunch of tools on top, such as the move, which is using W. You can rotate by pressing E, and you can scale by using S. So the scale you can just, and then now it'll be much bigger ramp. You also can rotate by clicking, and then now it will drag around its pivot. Okay, there are many other transforms that you can play with. you can understand. Okay, so as always, to undo is Ctrl Z. To redo, it's not like Microsoft Word. It's like every other open source software like Blender, Krita. You press Ctrl Shift Z to redo, just in case you undo too many times. Okay, someone private message. I don't see the rectangle when I go to preview. Is it supposed to be like that? Okay, so one thing I forgot to tell you is that there's something that I cheated with. So it's something called debug. So under debug, you'll notice that there's something called visible collision shapes. Pressing this will now allow you to see the collision shapes when you play the game. Okay, so do remember that we're pressing the play scene, this one. Now in this case, it doesn't really matter because if you press this, it will ask you to select a main scene. Knowing that this is our game scene, selecting this will be alright, and we'll still be playing the game. Okay, so ideally in your Godot game, in a very big project, you will have a main scene, something like called game. Then afterwards, you will have multiple scenes that are created like this. So you notice that there's this plus symbol right here. This plus symbol will now allow you to create more scenes. And you can create as many as you want, like your Google Chrome tabs. You can create multiple scenes. And with each scene, you can instance it, which we will show you later, when you really need it into the game. Okay, so the next one is, what is the red dot? What red dot? Oh yeah, so if you play the game, then this is red dot. It's a debug to show where is the contact point. Just in case perhaps you're clipping through something, or like your object is like spazzing out. Then afterwards they can show you the contact points in order to tell you if your game is for debug purposes. Yep. There are also multiple debug options here as well. Okay. Someone says my rectangle is not showing up when I click play. Okay, so the rectangle is not showing up. Okay, it will be invisible, and you want to make sure that in order to show its existence, you would like to place it just below the ball, just to show that there's collision shapes on. Another way is that you can, of course, go to debug. So I keep pressing the wrong button. Debug, and then there's this visible collision shapes checkbox right there. With the visible collision shapes, you can see in blue boxes. Okay, so with that, let me go back to my presentation. So now we have done all of that. Let's give you some time to do this. We'll be going through this, and this will be the bulk of our workshop for today. We'll be making a very simple game. Now this game is recommended by Godot. You can find its documentation. If you feel that perhaps today you're not feeling like doing it, or like you think that you are not able to keep up with it today, like if you're severely lagging behind, then afterwards you can my helper would send a link to the official documentation for it. So you can find the game over there, and you also notice that we'll be creating the game as I guide you through it. So the game is very simple. It is something like, it is basically you move the character around, which is a single-eyed organism, and it'll be moving around trying to dodge objects flying around. So you notice that this game has been recreated in HTML and other types of games, and it's a very simple game. There's no win condition, but there is a lose condition, and your score increases so long as you are surviving. So 1 score per second, right? Due to time constraints, I doubt that we'll be able to finish the games completely. However, we'll be able to get you through. I expected that probably. I promise that we will be able to show that the objects are flying around, or at least the mobs are flying around. You can die and you can move around. Okay, we won't be focusing too much on the UI. Okay, like for example, the numbers, the start button, all that kind of stuff, because we might not have enough time. Okay, so also another side note is that as I show the game, for the scripting part, we will start off slow and I will show you the scripts. However, sometimes I do understand that some people are not able to copy the code really diligently and really quickly. So what we will be doing is that we will be copying and pasting the code as well, just in case you are lagging behind. Just remember to copy and paste in the right places. Okay. Don't worry, I will explain any of the copy and pasted codes. I'm not the type of tutorials that don't explain anything, and we'll go through them thoroughly. Okay, so knowing the basics of the game is proper. We also want to discuss some of the specific elements. Okay, so now is a good time to get the assets. If you have not, I think there's a link that is sent to your email that was already talking about the, what's it called? Yeah, the link to get the assets. So for example, the asset for the mobs with the animations. Those will be given in the email, and it's expected that you have downloaded them. Right? Now let's inspect this game further. This game might not be as simple as we think because the enemies are random, right? They also have a direction that is always facing towards the center of the screen, or at least in some direction towards the screen. They are also, having animations. The player also has movement, and it is something that changes. So for example, the animation of the eye is moving upwards, and if you turn left or right, the player would flip back up. So if it's upside down, then it will flip back up if it is moving left or right. Okay, we'll demonstrate that in further detail later on. Okay, so now that we have not, let me see if there's anything. Okay, there's one more question. Okay, so undo, okay, let me just answer some quick questions. So undo is Control Z, redo is Control Shift Z. So 3 buttons at once. Yeah, Control Shift. Okay, thanks. Questions and answers. Okay, someone also lost the view of the icons. Is there a button that I can press to navigate to the circle and the rectangle? I have not experienced that before. So if you have lost the UI, it's probably because of a button under view or something. I'm not sure, but I don't think I can. What's it called? Move. I need to move on quickly. So do private message any of our helpers right now, just in case you have any questions and are a bit shy. They are tagged with the tag helper on the front. Okay, so now that you've downloaded the Dodge assets, you'll notice that it's in your downloads folder, and I expect that everyone knows how to extract. So let's extract this. Okay, you can use WinZip, 7-zip, and then you can extract the files. Okay, I have the Dodge assets. Yeah. Okay. So with the Dodge assets, let's create a new folder, a new document. So now there's this physics showcase, I can exit. So you can save it if you want to keep the physics engine with you. And I will exit the editor now. Next, I want to set up Godot once more so that I can show you, so that we can get started on our game. So let's start up Godot and let's create our game. So remember, this game is called Dodge the Creeps. Okay. So this game is called Dodge the Creeps, and I will create a new project called Dodge the Creeps. However, my game is already there. So I'll call it Dodge the Creepers to prevent any naming errors. So I'll name it Dodge the Creepers. I'll create a folder in my Godot folder. Okay, and I'll create a folder that is specific to this Godot game. Right? So we'll create and edit just like we did just now. And we'll be brought back to a fresh new start. Okay, we'll be making this game straight from scratch. It'll be rather fast-paced and do attention, hopefully. Yes. Okay, so now we'll move to the 2D scene. As always, this is our 2D scene, and just like we seen just now. What you notice is different from the previous game is that this game is portrait, whereas our game is landscape, just like the physics I showed you just now. To change this, to change the boundaries of the blue border, to change the boundaries of the game, you have to go into something called project settings. Okay, so it's right here, project settings. So the project settings is going to affect everything that is specific to your game. So this game only. You also notice that there's this other settings called editor settings. This will affect your Godot entirely. So for example, your preference, for example, to redo is Control Y instead of Control Shift C. You can change it here as well. Okay, but here we go into project settings. So do click on project settings. Okay, what we want to change is the window. So when we start up our game, the window should be different. The window should be different. So we want to search up a property, search up a setting called window. So press on this button, search, and then type window. Right? So you'll filter out all the settings for you, and you notice that there is this window setting right here. All right, here there are some settings for you to change specific to the project. There is the width and the height. Now listen very carefully. We want to put a width of 480. We'll click on it and click 480. And for the height, we'll go with a 720. So this is a very common aspect ratio that we expect in mobile games. Okay, so everyone caught up with this part. Must be 480 in width and 720 in height. Next, under stretch, we scroll down and we see under stretch. So remember this, okay? Scroll down, go to stretch mode. There's the stretch mode that is 2D. Okay, so what this does is that when you stretch the window, much like what you do here, if you want to minimize the window, you stretch it, right? It will not increase the canvas of the game. Okay, so this is expected behavior. We don't want to allow the player to use their 4-4 breaking skills to increase the size of the canvas and then allow you to see enemies coming from beyond the boundary. Okay, so we want to set the stretch to 2D such that if you stretch the window, the everything beyond the boundaries of the game will be colored black. Next, what we want you to do is to change the aspect. Okay, you want to keep it. So this will keep the aspect ratio, such that if you stretch the screen, your character doesn't look like a fat pancake. Okay, so it must be a keep. So you must keep the aspect ratio. It will be a 4:3, I think, 4:3 aspect ratio. Right, so remember, 3 things to do in this window. 480 by 720. Next, stretch mode, 2D, and aspect is keep. How do you find this? Remember that the setting is under the display, under window. You can search up by searching any setting using the search function. Okay, knowing this, we'll close out of this window and we should be fine. So what you notice now is that your window, the blue border, is now a portrait mode with the boundaries as shown. Okay, while I'm doing this tutorial, I will be referring to my notepad to show the instructions. So the next step we want to do is to create a 2D scene. All right, our game is 2D. We want to name this our player. Oh wait, hold on. Yes. Let me change something. Wait, let me see something. Okay. All right. So let's create our player character. So instead of creating the game first, we'll try to create our player character first. So we notice that this is a 2D scene already. However, this is not the node that we want. If you feel that you have made a mistake in your node, you can always right-click and to change the type of the script, type of the node. So this is a generic 2D node. What you want to do is that you want to change this to A, area, 2D. Not the red one, it must be a blue one, because all 2D things are blue in color in Godot. So select the area 2D node from our catalog of nodes. And now you have changed the node from a generic 2D to a area 2D. All right. So now Godot is complaining that there is some kind of missing shape. So as just now, like I showcased, let's add a shape. Yeah, we should be used to this already. So let's add a collision shape. It will be a simple shape. And why is it a shape? Why is it an area 2D? It's because in our game, our player is simply just an area. You can treat it like a moving rectangle with a shape of a single cell organism. So that's how it looks. Okay, so our collision shape has no shape. So let's select the shape as always. And what we want to select is a capital 2D. Okay, remember capital 2D. So don't try to select circle or anything. So why do we select capsule 2D? It's because the character, our avatar, is most resembling a shape of a capsule. In other words, an ellipse. Okay, so what we want to do next is to give the player a look. So this is definitely not our player. What we want to do is that we want to insert the player animation sprites. Okay, so this is when we use our assets. So you have downloaded the assets as mentioned from just now. And the assets can be found in your downloads folder. So with our assets, you just drag and drop it into your file system. Okay. Now Godot will be importing everything, and now you notice that you have your direction sets. So very important step. From your Windows Explorer, or if you're on the Mac, from your Safari, or what it's called. Yeah. You will drag and drop your folder, which has already been extracted, and drag and drop it into your root folder. Now you notice that there are some folders inside that you can explore. They include the font and the sprites. So the sprites include the player sprites. There are 4 sprites. Okay, you notice that in the game that was showcased, the player has different frames. One frame from making its pupil look to the right, another frame from moving up, another frame for walking, another frame for doing all sorts of stuff, as shown here. So what we want to do now is that we want to give it its look. However, unlike last time, let's make it a animated sprite. Okay, so you type sprite, there's 2 types of sprites. You want to select an animated sprite. Okay, an animated sprite would allow you to insert frames into the player. So now you have 2 things. Okay, you have an animated sprite that is complaining, that is empty, as expected. So let's insert the frames. So there's this frames here is empty. Let's click on it and select the only option available, new sprite frames. Okay, with the new sprite frames, let's click on it again. Okay, click one more time. Now you will open up with this. Okay, so this is something called the I think it's called the operation panel. So operation panel is located at the bottom. It's different from your viewport, which is located at the top. This operation panel differs depending on the node that you're selecting. So since you're selecting an animated sprite node, it will have the sprite frames operator panel. So this is expecting us to input some frames into the node. So we have the default animation here. Let's rename that. Let's rename it to walk. Okay, so this will be the default walk animation. With our default walk animation, we want to insert some frames. So with the walk node selected, we want to select the walk 1 and walk 2 that is located in our art assets. So drag, drop, and you notice that the sprites have appeared. Okay, so this is when it's looking to the right and you're moving. When you move to the left, you want this image to be mirrored, something that we'll teach you on later on. Now you also notice there's something called up. So this is when the player moves up. So what you need to do is that you want to click on this little button right here called the animations. So this animations right here is very important for you to create a new animation. So click on this. Okay, and now you have a new animation. So let's rename this animation as up. Okay, so you have an up animation and you have a walk animation. Let's do the same thing. Let's drag and drop the up sprites into our animation frames. So that means that now we have 2 different types of animations for this animated sprite. Okay, now you notice that this image is not moving. In order to move it, what you want to do is that you want to set the playing option to on. So if you want to play the animation, let's go back to our sprite. Select our sprite one more time, and now you go back to its original panel. What you'll notice is that on your right, you'll be inspecting the animated sprite node. Under playing, you can click on and you can test the animation. Okay, you can get rid of this. Now you notice that the animation is playing. Yes. Okay, let's stop. Now if you stop it, you might be unfortunate enough to get frame 1. So reset it back to frame 0 that is where our animation will start from. So we don't want the frame 1 to be starting like that. So frame 0 is the default animation. Alright, and now our playing is stopped. Okay. With that, we have completed the looks of our player. So let's rename this node 2D. Okay, last step, rename this player node 2D to player. This will signify that this node is our player. Alright, what I want all of you to do is to save the node. Save the scene now. So with Control S, you can save the scene, and let's save the scene as player.tscn. Okay, we have saved the scene. And it's now in our memory. So now you can notice that it's a player scene right here. Okay, so next up, what we want to do is that we want to make sure that this sprite is a little smaller than it is. So it's a little big. Notice that our screen size is this small. So we want to make this sprite a little smaller. To do this, we want to make sure that the sprite is transformed in a way that is 50% smaller. To do so, we go under the inspector panel, selecting the animated sprite. Okay, get rid of this, it's very distracting. With the transform, you can notice that there's something called a scale. So let's make it very specific. We will not use the tools like we've done just now. Let's make it 0.5 on both X and Y. So now it's scaled to its 50% of its original area. Okay, so now you notice that it's a reasonable size for the fit of the screen. Okay, so that's our animated sprite. Done. Okay, next up, what we want to do is that we want to give our player some movement. Okay, to do so, we want to create something called a script. So this is when the stuff gets spicy, and then we have to do some coding. All right. Let me see if people are catching up. Yep. Okay. Helpers are helping. Very nice. Thanks. Okay. So what we want to do is that we want to attach a script to the player. Okay. Now this is very important. We want to select this button right here. Okay. This is a very important button. It will allow you to code the game. With our script, we can code the player's movement. So let's add a script. Now you will notice this window. So the language we'll be using is GDScript. You'll notice there's native script and visual script. We'll be using GDScript because it's the most supported in the entire Godot. Leave the rest blank. You can even leave the template as default. And now you want to create this script. So press create. Okay. And now you notice that Godot has a bunch of stuff for you ready. Okay. So this is the code of the game. Okay. And it has put in the default template for you to put in any code that you want. So this is just a template. You can delete that. Okay. Next up, what we want to do is that we want to define the player speed. So if you have done programming before, this will be not too strange to you. Is that we want to create a variable that is rather used in the entire document. So let's create a speed variable. And in Godot, you don't need to specify. You need to specify the keyword var. Okay, so with the keyword var, it will create a variable. And now we'll set this variable to be 400. Okay. Next up, what we want to do is that we want to create a variable screen size. Okay. Variable screen size is uninitialized, so it will be like this. Okay, so what's so important about this and this? So speed, it will be something that determines how fast your player moves. It will be used to determine, it will be used to easily modify the speed just in case you want to do some balancing on your game. Okay. Now you'll be wondering, what does this export keyword do? Okay. So this export keyword, you'll notice that if you select the player, this appears. Okay. This is the speed variable that you just created in your script. It has appeared on your inspector, on your 2D viewport. See, notice that we're in the 2D viewport. So if we go back to our script, if we minus or if we subtract this export away, nothing, there's going to be no errors. And then if we go back to our 2D viewport, the variable is gone. So what this export keyword does, right, is that it simply makes it such that the variable can be edited from outside of the script, allowing you to easily modify the variable. So now, if I go back, I can just easily change the speed to perhaps as slow as 10 or negative if you want. You can click on this and you reset back to whatever default value you have set for the script. Okay, let's go back to our script viewport. So this is determining our speed and our screen size. Why is screen size important? It is to prevent the player from moving out of the boundary. So imagine if the player needs to know where is the boundary of the game. It cannot move out of the screen. So by specifying this variable, it will now store the dimensions and the boundaries of the screen. And if the player does manage to exit out of the boundary, we will clamp them right there and there, and they will stop. Okay. Okay, next up, what we want to do is that we want to create something called a ready function. Okay. So in Godot, unlike Python, whereby you use def, you use the keyword func. So what does func do is simply defining a function. So let's define a function that is already built into Godot. By convention, typing underscore indicates a private function. However, you also notice that there is a bunch of suggestions as you type something into the Godot func after the keyword. All of these indicate some kind of function that is built into Godot. For example, you have something called handled key input that senses for your keyboard key presses. So if you press W, you expect this function to be able to sense that you have pressed W. Now, there's also a bunch of other functions that is inbuilt into Godot, such as the physics process. This makes sure that the whatever thing that you put into your function will run every single frame of the game. So if your game is running at 60 frames per second, this process will run 60 times per second. Okay, but what we want is something called the ready. So do select the ready function, so underscore press ready. Okay, now Godot will stop complaining. Now Godot will start complaining, saying that you need to put stuff into your ready function. So what does ready function do? Now this will be a good time to introduce you to things that you really need and that will really help you as you do coding in Godot. One thing is to press F1. If you press F1, okay, you'll open up a documentation. So this documentation literally documents everything that can be found in Godot, from the nodes to the basic game engine on how you can speed up time and all that kind of stuff. Okay. So this is very useful. If you ever want to search for something, for example, you don't know what the heck does export do, okay, or like you don't know what does ready do, you can type ready, and then afterwards you notice there's a bunch of signals and other things. If you click on it, you'll notice that it gives you the full documentation of what each function does. For example, remove from group. What does it do? It removes the node from the group. That kind of stuff. Okay. So going back, you can click on the player.gd. If you have a gaming mouse, you can use the fourth mouse button to go back. Okay. So with the ready function, this function, okay, the second thing I want to show you is that how to quickly come out with the documentation instead of pressing F1. You can control, now I'm holding control, now control click. Control left click will now bring up a documentation of all the functions that you need. So for example, it will tell you whatever you control and click, what it does. So what does the ready function do? It runs whenever the node is ready. So in any game engine, every single resource is loaded according to a hierarchy. So the main game will be like this, and then perhaps you have a normal game like this, and then you have a bunch of nodes such as the player and all that kind of stuff. The player will be loaded after the game, so sometimes there will be a lag in between. To prevent your game from glitching out, what you want to do is that you want to declare variables that is needed by the player into the ready function. So going back, let's go back to the player.gd. Okay, so in the ready function, all the lines of code that we're writing in here will run when the node is ready. In other words, when player is ready. So let's create a thing that allows the ready to run. Okay, what we want to do is that we want to initialize our screen size variable. You notice that our screen size is not initialized. That's because instead of initializing it here, we want to initialize it here such that the game is loaded, and then now you can sense what is the screen size. So this is a code. Okay. You want to get the screen size and you want to set its value to be the viewport rectangle dot size. Now, how do we know what the heck this is? You'll be like wondering, we might be frustrated. Like, how do I know what this is? Well, there's a bunch of things you can get. So a getter allows you to get some value from it. There's a bunch of stuff you can get, and the one that we so happen to use is something called get viewport rectangle. Okay, get viewport rectangle. So what the heck does this do? Just control click, and you'll notice that it brings up the documentation again. So what does get viewport rectangle do? It returns you a rectangle2 variable. So notice that this is a data type, and it then returns you the viewport in terms of rectangle2 2D as the boundaries of a rectangle 2D. Okay, so the viewport's boundaries. In other words, whatever is specified in our project settings. See here, width. So now it will store 480 and 720 into a variable called screen size. So screen size will hold a variable that is of type rectangle 2D, rect 2D, and it will hold the size. Okay, so you press dot, you'll notice a bunch of properties and methods can come up. So you press size will return you the property of the screen size. Okay. Okay, so much like Python, the indentation matters. So this will return you the size of the viewport. In other words, it will return you 480, 720. Knowing this variable will now be important for us to decide the boundaries of the player and to prevent them from moving outwards. Okay, next, what do we want to do? We want to allow there to be movement. So to allow the player movement, you may copy this code. Now what we want to do is that we want to create a function, and we want a function to sense for key inputs. Okay, we can do something called physics process. Okay, if you type process, there's two types of process, but the one we'll be using is called physics process. The physics process will now calculate every single thing that every single frame where the player is and what the player will be doing. Okay, so you may copy this code, and as I will also help you to bring the code down into the Zoom chat. So you might want to what's it called? You might want to copy this, and I'll explain to you what each of these variables do. Okay, so these variables. Okay, someone's asking us whether we want to take a break. We will do so after we finish the player scene. Okay. All right. So the next thing we do is to input this. Okay. If you know what you notice is that if you copy and paste, the indentation disappears. So you could do a quick fix. You might want to press Shift and add, and tap again. Now you notice that the indentation is back. You also can do it manually if you feel that it is bothering you. Okay. So what does this do? Let me explain. It will now create, in every single frame of the game, it will create a variable called velocity. Now velocity is of type vector2. What is vector2? So let's control click, and then you can see that all the documentation. I'll give you a brief description of it. It is basically storing a 2D vector. In other words, there's two values. It contains the x value and the y value. If you have nothing in the parentheses, in other words, you pass no arguments into the variable, this will be empty. In other words, it will return 0, 0. So this velocity is 0, 0. All right, that makes sense because you're not moving at all at the start. All right, so now we will try to sense for input. So if input is action press UI right. So how do you know what to do? So if you're learning a new language, right, you're like, well, how do I know that I'm supposed to press this? Okay, what you do is that if you need to input movement, you want to specify an input. So an input, right, is colored the same color as the vector2, specifying that it is a data type. Okay, so the input is something that you will sense from your keyboard. So if you press WASD, it will now sense input. Okay, now you'll notice that there's a bunch of stuff that you can put in that is a property or a class of input. So you type is something. This will give you a boolean. So is something. Is action press, it means that you just press the button. Is action release, means that you release the button. Is action press or is action just pressed. Those different type of signals. There's also support for joysticks, mouse buttons, and other types of input. So what we want to do is that we want to pick the is action press. Okay, is action press would be different from is action just press. You read about it using the documentation. But now we want to input a argument. There are different types of buttons that you can input. There is the right button, the set button, which is probably enter, and home, left, page down, all those type of buttons. One that you want to care about is probably the button right. Okay, so I'm just copying whatever is down here. It is simple enough. So if the input that you're pressing is to the right, what you want to do is that you want to make sure that the player's velocity will be increased to the right side as well, as you expect. Now, if you refer back to your coordinate system, you notice that in Godot, we're using the fourth quadrant. That's why the screen is like this. So that means that, as expected, your positive right is to your right. A positive x, so your positive x is to your right. So as you move along the x-axis, it will increase positive. However, what you notice is a little unusual is that if you move downwards, your y is increasing. In other words, if you move down, it is positive y. Okay, this is unlike your Cartesian plane, so this is different, whereby your y increases as you move down. Now this makes complete sense because of the way that Godot makes it such that you are using the fourth quadrant only. And so what you want to put here, if you input right, your velocity, and remember that velocity is a vector 2D. Now vector 2D has properties, all right? The data type has properties. Two of its properties is x and y, because it's a 2D, right? So it has x and y. So let's put x, okay? The velocity dot x, in other words, the x component of its velocity of the vector will now increase by 1. So plus equals 1. All right. So from now on, right, it is simply just copy and paste. So what you can do is I can copy this, and then afterwards you can paste it 4 times. 1, 2, 3. Okay. So all you need to do is just change the velocity. Or it is the input. Sorry, you change the input. So this is UI right? So that means that x will increase by 1. Let's change this to UI left. Okay, UI left. So now what you expect is that you go the opposite direction. So minus equals 1. Okay, if you press, okay, now let's go up. So UI underscore up. Okay, so what you expect is that you're going upwards. But remember that upwards in Godot is negative y. Yes, so it is velocity dot y. Now you're going in the negative direction, so minus equals 1. And lastly, UI down. So for all 4 directions, you'll put in a velocity increase. Now you increase the velocities component in the y direction by 1. Okay, let's take a break here. Okay, that's someone's. So any questions to ask right away? Okay, so someone's asking me, how do we add the canvas item and node rectangle to scripts? Okay, so how do you add the canvas item and rectangle to scripts? There's no scripts here, but these are just the basics. So if you're talking about the inspector, these are the properties of each node. So for example, area 2D is if you see from here, it extends area 2D. In other words, this script is a subset, or it is inheriting all the properties of its class area 2D. So with this, it goes back to the inspector, and you notice that the collision, all the stuff is all here. So that means that the canvas item, node, all of that is not a script. It is just a property of the class that the node is inheriting. Okay, next question. Can you paste the code again? I paste it and it becomes it comes out as one line. Oh, okay. Hold on. Let me copy and paste the code again, just in case. So this is the process. Okay. Okay, next question. What's the shortcut for the documentation again? It is F1. Okay, so F1 is documentation. Now you can find out by pressing F1, and then you can search up anything that you want. It has even prompted you to put in the documentation, put in the search. Okay, so can you explain the ready function and how the game hierarchy works again? Okay, so let me draw it out one more time. Oh, wrong button. Yes, okay. Hold on. It's not working. Okay. So in your game, you have a bunch of nodes. This player node is just one of the many nodes that you have. So you have one node here that will load, and then afterwards, next it will load a bunch of other stuff, such as the enemy. Like, okay, enemy. I'm putting too much words, it's too big. Okay, so yeah, there's an enemy and then there's a player scene. So the player, right, would load after the game. Okay, so if it loads after the game, you do not want to create the variable screen size. Okay, let me get another color. You do not want to create a variable screen size too early. So you only declare it, you only initialize it in get viewport rectangle. You only get it after ready. So the node, once the node is ready, then you'll run this function. If not, if you put this equal get viewport rectangle dot size outside of this function ready, it means that it will try to initialize the variable when it's not even ready yet. Okay, so that's how the node works. So you need to be very careful whenever you think about the game's hierarchy and the game's like running process and how it runs differently. It's really not that difficult. You can just always use the function ready to put in any and initialize any types of variables that you're not too sure of. Okay. If it comes out as one line, you can create an empty notepad, paste the code, and then copy again for notepad and paste. Okay, thanks. Yep, thanks for the tip. Okay, so once I have enough water, I will begin again. Okay, you run the game, do we get an error? Okay, let's find out. So I have this additional line, I haven't went through it yet, but we will try to run the game. Okay, not the game, but run the scene, because our game is not ready yet. We don't have the enemies, we don't have the scene. So let's run the scene. You can press F6 or you can press the clapper. What you notice is that your player is at the top left because it was positioned that way. So let's try to move. Okay, we're not moving. However, the animation is in fact playing. Okay. Now this is not the same case for you because there's this line right here. If you didn't copy and paste, there's this line right here that says the animation should play. Okay. So let's continue. Wait, let's see if there's any more correction. Okay. Yep. That's right. So like what Julian has said. Okay, so let's begin with let's resume. So next, what you want to do, right? After you have defined all the movements right here, you want to create. You might notice one problem. So if you have learned vector mechanics, what happens when you input right? When you input right, it will increase your x velocity in the x component by 1. Okay, so initially it's 0, now it increases by 1. Now, if you're pressing down, okay, let's put it yellow. If you're pressing down, it will increase your y direction by 1. Okay, what if you're pressing both at the same time? Okay, if you press both at the same time, you get this problem whereby your resultant vector has a magnitude of 2. Okay. So that means that your velocity will be around like 1.4, which is not fair. So what you notice is that your character is zooming across the entire map if you're pressing 2 buttons at once. Okay, so let's try to avoid that. To prevent that, you want to use some vector maths to help you. Alright, so that means that we want to make sure that if you're pressing any button, number 1, so that means that if you're moving, so what does this do? So you type in here if velocity, and the velocity is a vector, remember that, dot length. Okay, length, right, is simply magnitude. Okay, if you're not too sure, you can control click, and then it says it returns you the magnitude of the vector. Okay, so your dot length is returning you the magnitude. If your magnitude of your velocity is more than 0, in other words, you're moving, then you will run this function, or run this code. So what does this do? It sets your velocity to be whatever it was before. So if you're pressing down and right at the same time, your velocity will be assert 2. So what you want to do is that you want to normalize. Normalize makes it such that you will make it into a unit vector. Now you can always control and click. This time it won't work because now velocity is not defined as a vector 2D. So here will be a good time to use your F1, and then you can type in normalize, and then you can search out what does normalize do. It's a property, and it returns such that wait, oh, there's no description. Oops. It basically makes it such that you turn it into a unit vector. So what's so good about unit vectors? Okay, so this time you use a unit vector, right? They're all ones. So 1 times anything will give you that anything. So if it's 1 times speed, now your velocity will be speed. Okay? So the speed you have defined it here already. So now it will be set. It'll be a constant 400. So whatever you do, right, you will now be 400. Okay? And as a last touch, we will have to play the animation. So what you can do is that you can do something called, you can call the node and then you can play. So here is a very important thing about Godot. It is something called the dollar notation. So in many other languages, you learn very funky type of notation, such as the double one, which is a bitwise shift. And then you have like, I remember there's this like really weird notation in Java, which is the add symbol. But in Godot, you have this weird symbol called the dollar sign. Now don't worry, it's very easy. It is simply getting the node. So when you type dollar sign, right, you will basically suggest you a bunch of stuff. It will suggest you the animated sprite and the collision shape 2D. You'll notice here that your animation sprite and your collision 2D is right here. So what this dollar sign is trying to get you, right, is basically it's trying to call the node. Okay, so if you type the dollar sign, now you have 2 options. You can call yourself, you can call the animated sprite, or you can call the collision shape 2D. Let's call the animation sprite because you want the animation to play. So animated sprite. In the inspector, you notice there's a list of all its properties right here. It is also listed in the documentation if you control click. But one thing that we want to do, right, is that we want to play this animation. Now by default, it is not playing, as it should be, because you don't want the animation to be playing while you're not moving. So therefore, it should be off. In order to play it while you are only moving, go back to your script, and then afterwards, here you really say that velocity of length more than 0, right? So that means that your player is moving. If your player is moving, your animated sprite will now play the animation. Okay. It's a method of any type of animated node. So the animated sprite node, it will notice a bunch of properties. What you want to do is you want to play. Okay, to play. There's also another function which is to stop. So accordingly, if you're not moving, in other words, the if fails, then you go to your else statement. Your animated node will stop playing. And here you put your stop method. Okay. So that's it for the movement. I think there might be something else that we need to win. Okay, next. I hope no one is too lost and that all the questions are answered. Okay, next what we want to do is that you want to copy this and paste this because we might be running short of time. I still have the enemies and all the stuff to go through. So let me just copy and paste this code just for you. So remember to paste this just below your physics process just below the else statement. Let me explain what this does. You'll notice that we have declared the screen size. We have stored it, but we have not used it yet. Okay, so this is when we start to prevent the player from moving out of the boundaries. Okay, so now that we have set the velocity to be 400 and it has a given direction, because you know that vectors are direction and magnitude, right? So now it has a direction and now it is times the magnitude of 400. What we want to do now is that we want to make sure that the position is increased by that velocity. So if it's 400, right, the next frame you'll move 400 units, and then you will times delta. Now, don't worry about the times delta. If you're new to it, you don't have to worry about it. Yeah, just put it here. Okay, if you want to know, delta is simply the time in milliseconds taken between frames. So this will help you account for lag. So if your game is like damn laggy for some reason, right, your delta will help to try to smooth it out a bit, because it takes into account the time. So if you're lagging for 2 milliseconds, right, then afterwards your velocity will times 2, and then afterwards you move 800 pixels in that direction. So it's basically a lag control. Now you also notice that there's something called a position. So it's colored blue. It's not colored black like the rest of our variables. Now this is because our position is local to our animated sprite, not our player. So our player, right, has the position. Okay, it's simply the same thing as saying dollar sign, like what we do, dot position. Okay, so you notice a bunch of them. One of them is the position. So you notice that it has a property called position. This basically makes it such that its transform is in the right direction. By not specifying dot, right, it means that we are just getting the position of the node that has the script. In other words, it is the player. Okay, so where is this from? How do you know that it is something called position? You just go to transform, there's a property here called position. Okay, now it will make sure that this thing will move around. So as an example, it will move it like this, by 800 pixels. Okay, now let's undo that. Okay. Okay, going back to the script. You'll notice that the velocity, the position will now move accordingly to the velocity, and it's based off a vector. Next, we want to make sure that the player doesn't go out of bounds. We have this keyword colored in red called clamp. You might not know what it is, so you can click on it. It basically makes it such that you will not move past these two values. So the first argument that it takes in is the value. Okay. Then the next argument it takes in is the minimum. So it cannot go beyond 0, or it cannot go under 0. This is the minimum value, right? So it cannot go under 0. In other words, if you go look at your 2D, right, it cannot go up here in your X direction. It cannot go up here in your Y direction. Makes sense, because you don't want to move to the first, second is the quadrant. Okay. Now, then afterwards, you specify your maximum value. Okay, your clamp has a third argument called max. So this max, right, is simply saying the screen size. So you got your screen size already, right? You store it as a rectangle, 2D rectangle. You get the X component of it. It returns you 720 in 480 in this case, which is your screen width. Similarly, in your Y, your maximum value would be screen size.y, which is your height of your screen. So that would be 720. Okay? Now, the value here, right, is saying that it will change the value such that if position.x is -5, it will clamp. In other words, it will change it to, so this entire function will return 0. If your position.x is 481, that means that it exceeded the width of the screen. It will clamp it to 480. So it will basically make sure that position.x will always be between 0 and the screen size x, and similarly for the y component. Okay, so this prevents your player from moving out of the screen. Okay, next up. Okay, we have to copy another last line of code for the player. Yeah, we can play right now. So to test out, you may want to play your character right now. It will be very interesting. Okay, so we can press F6. Now you can move. Congratulations, you have made your first fully working character that can move. What you notice is what is different from the actual game, right? Is that the player doesn't have any animation for moving up, down, left, right. Okay, so if it's moving down, it should be flipping vertically downwards. You also notice that there is no other stuff happening, but it has managed to successfully clamp itself within the boundaries of the game. Okay, cool. Next, what I want to do is the last line of code. Okay, so what I want to do is that we want to make sure that the animation play. Okay, so by control and pasting this, and I will paste it in the chat as well. So just like what one of my helpers has said, if you are lost and you have completely a non-functioning script, right? Don't worry, we will send you a complete version. Then afterwards, you can take your time to compare what went wrong with your script, and then you can learn from that. Okay, so the last chunk of code that I pasted is this. So if the velocity is not equal to 0, in other words, you're moving in the x direction by some value, you will now play a walk animation. Okay, so how do you know what this is? How do you know that this is property? So you just go $, animated player, animated sprite, you do dot, then there's a bunch of stuff. Animation is one of them. And how do you know what animation it is? Then afterwards you'll be like, okay, let's go here. Animation. There's a bunch of animations right here, right? You got your walk animation, you got your up animation. It is these two. So if you don't know, you can always go back to your inspector and you can find some kind of inspiration from there. So $, animated sprite, dot animation will now be equals to walk. Then you'll be like, dude, how do you know that there's something called flip.v? Okay, it's also here. Okay, underscore flip v, flip underscore v. You hover over it, it's a flip underscore v property. Okay, then you go back to the script. Now we will set it to false. Okay, so in other words, what does flip underscore v do? If you are walking to your right, then afterwards you will be playing the walk animation. If you're walking to your left, you're still playing the walk animation. So as long as you're moving left or right, you will be playing the walk animation. Then if you are flipped downwards, because if you're moving downwards, then you'll be flipped downwards. You will be moving, you will automatically flip yourself back to its original position, and then you move left or right. Okay, this is expected behavior because you don't want it to be upside down and then moving left or right. You want it to be upright and then moving left or right. Okay. Now the last part. This is maybe a little confusing, but it basically makes it such that it's a Boolean function. So remember that flip y and flip v and flip h, right, must accept a Boolean function, a Boolean value. So what does this evaluate to? It depends. So velocity.x. If you're negative, it means that you're moving to the left. If you're positive, you're moving to the right. So if this is less than 0, it will return you true. In other words, if you're moving left, you'll return true. So flip.h, flip underscore h will be left. In other words, it will be true. In other words, you'll be flipping to the left. Okay? And similarly for the y direction. So else if you are moving in the y direction, you'll be playing the up animation. Okay? And then you'll be flipping your velocity. You'll be flipping your sprite upside down. It will evaluate to true if you are moving downwards. It will evaluate to false if you're moving downwards. Evaluate to true if you're moving downwards because down is positive. Yes. Okay. So if you're moving downwards, it will evaluate to true. Flip underscore v will equals to true. In other words, you'll be flip downwards. Okay, don't believe me? You can play the game right now. So I'm facing right. My eye is facing right. Now if I press left, the sprite will be mirrored. And now it will face the left direction. If I move down, the sprite will be upside down. It will be mirrored in the y direction. If I'm downwards and I'm facing downwards, and I press left or right, it will automatically flip itself back up. Okay? That's the aesthetics of the game. You can configure with however you want. If you feel that moving upside down is fun, then you can set this statement to be false. Yeah. To stay as is. Okay, so that concludes the player script if I'm not mistaken. Oh wait, no. Still some stuff to go through. So that concludes the movement. So this entire process, right? This entire physics process, that's done. So you have now a fully functioning walking player with animations. Okay. Next thing what we want to do is that we want to make sure that the player can die. Okay. So notice that in our game, the player can die. And how do we know that the player has died? Well, what we can do is that we can make sure that since the player has something called a collision shape, right? Okay, let's move this downwards. So do move the collision shape downwards to the lowest layer such that you can see the collision shape. Let's make sure that this player has a reasonable collision shape. Okay, so by dragging the circles, you can create a suitable collision shape. Now, based on balancing details, you want to make it such that the shape is a little away from the edges. Else your player might rage quit because it is way too hard. And now you want to make sure that it is just fitting nicely around the edges of your player. So do a little bit of adjusting. And now you notice that the edges are like that. Now, the legs will also not want to be included, or else it will be a little unfair for the player. Okay, so now you have created a suitable collision shape. If you cannot see the collision shape, it is because your collision shape is above in the scene tree. Remember that. So now we have a collision shape 2D and we want to create this. Okay, so now it's 9:30. We'll be continuing on until 10 o'clock, as mentioned in the start. Okay, so if the collision 2D, that is your shape of your player. If it ever collides with another collision shape 2D, we want to make sure that this player will die. In other words, it collides with another enemy. So let's move on to the signal. So let's create a signal. In other words, let's create an event. This signal will be called hit. Okay. Hold on. Yeah, it's called hit. Okay, so do create it at the top of the scene. Okay. Also, under your ready, you want to add another line called hide. So what does this do? Hide basically makes sure that your player is unseen. So until the node is ready, then afterwards it will show itself. Okay. So with the signal hit, now what you notice is that if you go back to our player script, right, you notice that there's this new signal called hit under the inspector. It's specified by the player Godot script. Okay, going back to this, we'll remember to use this hit scene when the player is hit by itself. Hit by another enemy. Okay. Next, what we want to do is that we want to go to the inspector panel. We want to make sure that the player is going to be sensing a signal whenever its body is entered. So if something enters its collision shape, right, then it will emit a signal called body entered. This is a built-in signal, and it will run whenever it is colliding with something else. So let's double-click on this. Okay, what does double-clicking do? It will connect itself. So what does connecting do? Connecting a signal makes it such that it will sense an event, and it will have an event listener on. It will declare an event listener somewhere wherever you connect it to. So what we want it to be, right, is that we want to emit a signal, and then we want to receive the signal. Okay, so we want to listen to the event as we emit it. Okay, why does this make sense? Because the player is going to kill itself the moment it collides with something. So double click on body entered. Okay, remember body entered, body entered. Okay, then afterwards you select yourself. Okay, there's nothing to select here, so you just click connect. Okay, with that we click connect. Now what you notice is that you create a new function called onPlayerReceive body entered. What does this do? It makes sure that if you are collided with something, it will run this function. Okay, you notice that there's this green symbol indicating that this is the event listener. So what you want to do next is that you want to put in a this one. So put in this code. Oops, put in this code. Okay, so this will appear underneath your this will appear underneath your function on player body entered. Remember to paste it right there. What does it do? It will hide the player, basically making him invisible, such that it will give the illusion that you're dead. Then it will emit a signal got hit. called hit. Okay, you got a signal hit here, right? So now you emit the signal. You emit the signal outwards, and then afterwards, whoever will receive the signal will then sense it. Next, what you want to do is that you want to set the collision shape called do the set deferred, which basically makes it such that it will be disabled. Okay. So what does set deferred do? You will basically make sure that the collision shape under the inspector is this thing called set deferred. Okay, disabled. So set deferred makes sure that one of its properties will be set to off. Okay, so now you disable the collision shape. Why do you need to disable collision shape? It's because if your two objects are intersecting one another, if it's continuously intersecting one another, it will cause a lot of signals to be emitted. So what you want to do is that you want to collide, stop the thing, and then afterwards, stop the collision, and then afterwards, now it will stop emitting signals. Okay. So next up, what we want to do is we want to create this function. So to paste this to your script. So you create this function called function start. Okay, you can copy and paste it at the top of your script. What this does is that it will set the position of your player to its default position called pause, and then it will show itself. So unlike what happened in ready, this now will make the player and will show itself after it has run. Okay, and then afterwards it will now make sure that you have your collision shape enabled. Okay, so just make sure that if you die and you want to play the game again, it will enable your collision shape, it will return you back to your spawn point, and then it will show yourself, just in case you're missed. Okay, next. Okay, so this marks the end of the player script. Okay, so what you want to do is you want to press Ctrl S and to save the scene. Now what we have to do is that we have to create the enemy scene. Now, I'll be going a little faster, and of course we are kind of short on time, and we'll be creating the next scene. So press the small plus button up here. Okay, remember there's this plus button, it will create a new scene. What does this do? You will now create a new scene, and then you want to create an enemy. So, as always, we create a 2D scene. We can change the type by right-clicking and then changing type. Okay, remember change type. Right-click, change type. We'll change it to a rigid body. Why? It's because the enemy is a sprite. It has a collision shape, and it's basically kind of affected by the 2D engine. Okay, we'll rename this as enemy. And we will make sure that this enemy has a shape. So we'll add a shape like always, and we'll add a sprite. We'll add an animated sprite because we are given the animations. Okay, so under collision shape, we'll give it a shape. The shape would be a capsule, like before. The animated sprite will have animation frames, and then we'll input the animation frames. So we click on it, animation frames once more, like we did just now. And then we notice that in the assets, we have 3 different types of enemies. So as a life hack, what we can do is that we can specify 3 different types of animations to give the variation of enemies. So one, we name it as flying. We create an animation by clicking on the new animation button. And then we create a swimming. Then we create a third animation called a walking. There's 3 types of enemies: walking, swimming, flying. Then what we do is that we drag the animated frames accordingly. So flying goes to the flying animation, swimming goes to the swimming animation, and walking goes to the walking animation. Okay, what you notice is that the default is the walking animation. So now Godot has no more complaints. Okay, sorry, one mistake. Instead of naming this enemy, we name this mob. Then it will be the mob scene. Okay, now we notice that in the game, the enemies do not have gravity, whereas rigid bodies are naturally affected by gravity. So what you want to do is that you want to set the gravity to off. To turn off the gravity on this rigid body, you go to gravity scale after selecting the mob rigid body node, and then you want to make sure that this gravity scale is 0. Okay, now it will not be affected by gravity, and then you can float around the screen. Next, what you want to do is to make sure that the rigid bodies do not affect each other. So the mob cannot collide with another mob, right? So what you want to do is that under the collision shape, under mod, the node, you go to collision object 2D. Okay, go to collision. There is this mask right here. So there's a difference between layer and mask. Layer is where the node is in. Mask is what it affects. So if you're on layer 1 and you have mask 1, you affect everything that's on layer 1. Okay, if you're on layer 1 and then you have a mask that's on 2, you won't affect anything on layer 1, but you affect everything on layer 2. Okay, so let's turn off the mask. This makes sure that it doesn't collide with any of its other mob brethren. Okay. Next. So you have turned off the collision, right? What you want to do next is that you want to have the fly, swim, and walk animations. So I already put that, and now we set the playing. So unlike the player scene that we set as stop, right? It doesn't have any animation playing by default. Whereas for the enemy, we don't want to set the animation to play using a script. We just want to set it to playing by default. Okay? So all these animations will now be playing by default. It has 2 frames and it will run continuously. Okay, so next what we want to do is that we want to make sure that the collision shape fits perfectly. And also that the enemy is smaller. So let's make the enemy smaller first. So in the animated sprite, much like what we did with the player, we will change the transform and scale it down by 75%. For 0.75. For the scale, 0.75. Okay? That sets the scale of the mob to be a little smaller and we make the game a little fairer. Okay, next what we want to do is that we want to add a capsule shape and make sure that the capsule fits in perfectly. So what you notice now, right, if you move the capsule down, the capsule is not aligned. And no matter how much you do it, right, it won't be aligned. Because now the capsule is facing upright, whereas your mob is facing to the right. To fix this, what you want to do is you can rotate by using the rotate tool like we discussed just now. And then you can press Ctrl to snap it to corresponding positions. Or you can change the transform. When the transform, there's a rotation 90 degrees. You can specify the value to make it more precise. So let's fit the shape of the capsule accordingly to the mob. So make it a little fairer by making the edges not touch. If you want to move again, press W, or you can press the 2 again. This is a little too much. Let's make it smaller a bit. And now the frames look like this. Okay, fair enough for the enemy. Okay, so now all enemies have this collision shape. Next, what I want to do is that we want to add a script to the mob. So this will be quite heavy, but we expect that you will be able to follow through because we have done the script before already. So now let's attach a script to the mob. Much like what we did with the player, there's a script here. Now we'll attach the script to the mob. So we add a 3D script mob script, and it will look like this. Now I'll be copying and pasting some code over here. So first of all, what you notice in the game, right, is that the mobs have varying levels of speed. They have some randomness, and therefore it will be good to have some randomness as well. So to specify the range of the speed, you have the minimum and maximum speed specified as 150 and 250. Next, what I want to do is that we want to make sure that under the ready function, which is created, we want to make sure that the mobs have the frames. So what does this do? So it will create a mob types variable. It will store an array of animation names. So get animation names, right, will return you a pool string array, an array of strings. Okay. So what does this do? It makes it such that the mob types stores an array of animations, and in the animations, now you will determine a random So this is a very popular way to create randomness. First, create a random integer, and then afterwards modulo it by the size. So you can modulo it by 3, by 2, by 3, and then you can get a number between 1, 2, 3. Wait, 0, 1, and 2, because it starts with 0. So 0, 1, or 2. You have mock types, and you access the mock types array, and you will access it using the 0th element, first element, or second element by random. So this makes it such that the animation will be random between 3 different animations. Okay. So once the node is ready, it will select its animation. And next, what I want to do is I want to connect the exited signal to this. But let's create another node. This will be the last node of the enemy node. So add a child node, and let's create a visibility notifier 2D. Okay, double click, and this will be its node. So what does this do? It emits a signal whenever the enemy is on screen. Okay, so let's go to node. Let's go to node, and then there's a signal called screen entered, and also screen exited. Okay, so what we want to do is we want to select the screen exited node. Okay, remember this one. Okay, select the entered one, select the exited one. Okay, select exited one. Now you connect it to yourself. Why? It's because the moment you exit the screen, you want the mob to kill itself, so as to prevent any additional resources from being loaded by the game. Okay, so connect to yourself. Now you have a function that is listening to the event whenever the mob exits out of the screen. So when it exits out of the screen, you want to kill yourself. To do that, you want to do free. What does this do? You can read up on it. It basically makes it sure that this mob is not there. Okay, it will disappear. And it will be freed from your memory. Okay, so that's very simple. Next, what we want to do is we want to finish off. So this is the end of the mob scene. Now, as the final touch, we'll pull everything together, and then we'll create the game itself. So this is the end of the mob scene. Control S and save the mob scene. Now we have player, we have mob. Now we'll create our third scene. So click on this, and new scene. Let's create a new scene and call this a 2D scene. Okay, no, actually no, sorry. Let's call this a generic scene. Okay, so for the first time, instead of creating a 2D scene, we'll create a generic node. So at the top level, you create this node called node. Very simple. We rename this as main. So this is your main scene. This is where the game starts. So next time when you press this play button, right, it will start from here. And then afterwards, you'll load all the additional resources like the player, the mob, all those other scenes will be added on inside. Okay? So now, okay. It is called main, and now we have nothing inside of it. So if you go to 2D, there's really nothing inside of it. There's not even the viewport. Oh, yeah, there's nothing inside. There's no player. There's no mobs. So to bring some life to your main game, you want to instance them. So now I introduce you to this very important button called scene instancing. What this does is that it basically imports your other scenes, such as your player or your mob, into your game, into your scene. So now this main scene will have two scenes. We'll have a player scene and then we'll have a mob scene. So let's add a instance. So click on the chain icon, and then you will have two different options. You want to instance the player scene instead. Okay. Once you instance it, now you notice that your player has been brought to life into the main scene. It has also inherited all of the signals and the code and everything that we have specified before it. Because instancing, right, is basically just creating a copy of the player scene. So now your player.tscn is your template, and this is a copy of it. Next, what we want to do is that we want to create a bunch of nodes. So follow with me still here. Let's quickly add some nodes. So first of all, we'll add a timer. In fact, we'll be adding 3 timers. What does the timer do? It is very simple. It's a node that counts down the moment it is ready. So it'll count down, right? And then when it reaches 0, so for example, we specify that it has 3 seconds, wait time is 3 seconds here in the inspector, then it will emit a signal called timeout. Okay, now this will be very useful because it tells us when the game will run, or like when the enemy will die, or how many seconds you need to wait until the game is over. Okay, so we'll create one timer. This timer we'll call mob timer. What does this do? It'll make sure that every 0.5 seconds a mob will spawn. So to specify the time, go to inspector and set the time to 0.5. Okay, 0.5 seconds, the timeout will run and a mob will spawn randomly from the edges of the screen. Next, we'll create a score timer. Add another timer. And we call this the score timer. Okay, set this to 1 second as by default. And then afterwards, we'll create another timer called the start timer. So what you notice is that after you press the start button, right, mobs don't immediately start spawning. In fact, they will wait for 2 seconds. You can move around during those 2 seconds, and then afterwards they'll start spawning. Okay, so when you press start, then afterwards the enemies will take 2 seconds to start spawning. Make it fair. So now we change the wait time from 1 second to 2 seconds. Okay. Now this is the most important part of the tutorial. We want you to take away what you can do with the inspector rather than what you can do with the script, because the scripting part can first of all be a little bit more difficult, and also you can always copy it after the workshop. So next, what you want to do is that you want to create the last node of this scene. Okay, not really the last one, but the position. What does this position do? It basically specifies your spawn point. So we don't want the player to be spawning here, we want to spawn it around here. So what you want to do is that you want to transform the position, make sure that it is around here. So go to transform, we'll set the position of the start position. So we rename this the start position. We want to make this position 240 and 450. So if you didn't catch that, I will send the coordinates of the start position. Okay. So now we have the start position, and this will specify your spawn point. Next, what we want to do is that we want to make sure that this node, the start timer, right, is one shot. What does one shot mean? You can hover over it and you can have a brief description. It basically makes sure that this timer will count from 2, 1, 0, and then it will stop forever. Whereas other timers, right, for example, the score timer will repeat itself after reaching 0. So 1, 0, 1, 0, 1, 0. This one will be 2, 0, 2, 1, 0, and then it will stop forever. Okay, one shot. Next, you want to add a path 2D. Okay. But this path 2D is specifying the edge of the screen. You also want to add a child of the path 2D as a follow 2D. What does this do? It makes sure that there's this line across the entire edge of the screen, and then it will randomly spawn enemies that will face towards the center, and then it will move towards the center of the screen. Okay, so path 2D will now be renamed to mob path, and path follow 2D will now be renamed to mob spawn location. Okay, so now what we want to do is that we want to specify the edges of the screen. Okay, to do so, what you want to do is that you want to have this very fun little editor that adds points to the scene. So select on the green button at the top of your toolbar, right here. Oops, I accidentally messed up here. Right here. And now you can add a point. So you're supposed to add 3 points. So the mob path will be here. Okay, it will be at origin. Then it will be at here. So you can hold Control or Shift, and then afterwards it will move itself around here. You can even transform it around there. Yeah. Sorry. Yeah. So select one point. Then if you ever make a mistake, remember to Control Z. Select this point, the third one, and then select this point, the last one. Now you have this open square that goes from like this. So in order to close it, you press this button called Close Curve. Now this will close the curve and it will have a full box around it. So you have your mob path. It goes around the entire edge of the screen, and then afterwards you want to have a mob spawn location that goes around this path, and then it will spawn enemies directed towards the center. Okay. Now we create the main script. This main script, it will be the game script. It is the most important game script, and it will be created here. So just like normal, create it without any modifications. And now it is copying time. So let's copy this line first. So if you are still following and you didn't download the mock folder, I will set it here. What does this do? It makes sure that this is a mock scene. So we'll export. So remember, export resources. So we go to our main scene. There's this mock variable that is capitalized. This means that it is a class. And how do we put it inside? We take the mock.tscn, we drag and drop it into our mock variable. So now this will take on the form of a scene. So now the mock variable will contain a mock scene. Now this will be used later to randomly spawn the enemies from around the edges of the screen. Okay, I also commented this code right here. It basically specifies that you can use this line as well to specify the path towards the mock scene. Lastly, you want to create a score variable that will be used later. We also under ready, when the game is ready, it will randomize. So what this does is that it will reseed the randomness to create a more accurate randomness in the game. Next, what we want to do is that we want to connect the hit signal to game over. So remember that we have our nodes here, right? Our signals here. We created this hit signal just now. Okay, it happens whenever the player has its body entered. And now we want a hit signal to connect to something. So that when you're hit, you're instantly game over. So we want this signal to be connected to our main script. So we connect from our player to our main script. So when a player is hit, then afterwards it will tell the main script something. What do we want this something to be? Okay, we want it to be a function called game over. Okay, so on player hit, you will stop the timer. In other words, you will stop earning points because you're dead. And then afterwards, you will make the mock timer stop. In other words, you will stop spawning enemies. Much like what you see here, when you die, the enemies will stop spawning. Okay, so what you need to do next is to create a new game. So create a user-defined function, function new game. Okay. What does this do? It makes sure that you start your score from 0, and then the player node, which is this one, will start. So what is this function? How do you know that this function? Well, because we specifically said so. If we go back to our player scene by clicking up here, notice that this is the start function that we define ourselves. So it will basically run all of these code. Okay, so we're going back to our main script. Okay, we have the start. So player node will now start. Okay, and then we will pass in the position. So where is this? Our start position was specified to be 240 by 450. So it will get the position. Then we'll pass it into our start function, because our start function accepts one argument, which is the position, and then it will move the player to the start position. Then we'll also have start the timer. Okay. So after we start the start timer, it will count down 2 seconds, and then the game will finally begin. Next, we want to create a start timer countdown. So this is the part that might be a little confusing because you'll be connecting a bunch of signals together. So remember our start timer, it will count down 2 seconds, and then afterwards the game will begin. So to make sure that we are able to sense that the 2 seconds are up, we use the timeout signal. Double click on the timeout signal, and then connect it to our main scene. Okay, so we are connected to our main scene. The moment our start timer is up, we will now start spawning enemies. Okay, so that means that we will start the mock timer. In other words, we will start the 0.5 second countdown, and then we will start increasing your score because you're surviving. Okay, next up, what we want to do is that we want to create a timer for the score timer. So we notice that we have the score variable here, right? So now what we have to do is that we have to make sure that there's this new timer. So much like we did with the start timer, we'll also have a timeout for the score timer. So every single time it reaches 0, in other words, every second, you will emit this signal to your main script. And then you will increase the score by 1 point. Okay? Makes sense. Next one. We have 3 steps left. So this is the final chunk of code, and I'm kind of running over time. So this will be the last chunk of code that you have to copy and paste. The rest of the little bits of pieces that you can have here, right, is all created by connecting your signals. So remember your signals, you double click. Now this is the last chunk of code. I'll copy it and paste it to the chat. Okay, so this is the last piece of code. Now it's a very big chunk, and I'll explain what happens here. So this makes sure that you will call your mod path. So remember our note here, mod path. Under our mod spawn location child, we will have a dot offset. So this makes sure that we have a property. So remember here, our mod spawn location, we have an offset. So what this does is that if I increase it, right, notice that the position as it follows throughout the entire path. This is simply because the mod spawn location is a child of the mod path. So if you specify the offset, right, you will now have a random location, a truly random location around the edge of the screen. Now we go back to our script, and then we have a random integer. So now our offset will be a random integer. Okay. Then next we have a variable mod. Okay. So this variable mod, right, is simply an instance of the mod. So this capital B mod, capital M mod, right, is the class that mob scene that we have up here. So the mob scene, right? So this is the class. So now we will instance it. In other words, you'll create an object based on this template, this class. So now this small letter mob, right, is basically referring to an instance of the big class mob. It will inherit everything the big mob has, and so it will be a random mob that spawns in there. We will now add a child to this entire main script. So in runtime, as I'll show you later, it will create a bunch of these mob instances. Because now there's multiple of them flying around, right? So all those mob instances will be a child of the main scene. And then after it reaches the end of the edge of the screen, they will disappear. Like remember what we did in the mob scene. Okay, so next, we want to make sure that the direction is random. To do so, we'll make sure that the rotation is random. The rotation is 90 degrees, because this is radians. So pi divided by 2, that will give you 90 degrees. So how do you know there's this rotation property? Just go back to your mod spawn location. There's this rotation under transform. So rotation degree will be random. And you won't know what it is. Okay, so let's go back to our script. Then we also set a random position to spawn the mob. Okay, so the mob.position, right, would now be at the mob spawn location. We'll set it already here. So now it's random already, right? So therefore the position of the mob is also random. Next, we will set this direction to be 90 degrees because it's already rotated 90 degrees, remember? Then afterwards, we'll add a random range between negative 90 degrees and 90 degrees. So anything between around here and around here. So now you have a random direction, and then afterwards, it will send the mob in that direction. It will now rotate the mob in that direction, and then afterwards, it will send the mob flying using a linear velocity and setting the linear velocity to be a vector between its minimum speed and its maximum speed that we started off with the mob scene. So now we are connecting all the strings together. So remember these two variables we created at the start of the mob scene? At the start here? Yeah, now we will use them. And we will get a random integer between 150 and 250. They will now vary the mob speed. Okay, so now there's a vector 2, it is a random range between those two. Lastly, we also set the velocity to be a rotated velocity. So what this does is that it will now it will set the linear velocity to be rotated in that direction. Okay, so now with all of that done, we will now showcase you what is the game like, or what it should be like. Okay, sorry, I'm playing the scene. Okay, so what you have to do, right, is that you have to save the main scene. So Control S one more time and save it as main.pscn. Now we can finally play by pressing the F5 button, which is the big play button. By pressing this, we'll now select the main scene. So you say no main scene has been ever been defined, but now we have one. So let's select the main scene, and the game is playing right now. So what you notice is that, oh wait, hold on. We have a bug because I forgot to mention the position, and also to set a new game. Okay, last line of code, I'll paste it right here. Okay, the last line of code is that you have to make sure that when the main scene is ready, it will start a new game. Okay, our new game function was defined right here, whereby you start everything and all the timers. Let's play. And what you notice is that we spawn at our correct position. 2 seconds is up, and hold on, our mobs are not spawning yet. That's because we have not set the timer. Okay, so because our instancing, let me go check. We have our mob scene, and now we'll instance it together with the rest of the scene. Okay, I think I'm missing a step. Yeah. Okay, file system, mob property. Yep, okay, randomize, load scene, variable score. Okay. As always, in the game development process, you will encounter some bugs. So I think it's because my mob timer is not connected. Yeah, I think it's because of that. Okay, yep, okay, so sorry, last part that I found where the bug is. Basically, I forgot to connect the main scene. So go back to your main.gd, you can select it over here. You'll notice that this mob timer, right, is not connected. That's because it is not connected to the timer. So now we will select the timer from the mob timer. So select this one, and double click on the timeout for the mob timer and connect it to the main scene. What you notice now is that it is connected. And so you'll run all this code when the moment the mob timer starts. So let's play again. And what you notice is that after 2 seconds, mobs will start spawning. And you notice that they are pretty damn scary. Okay? So once you notice that after you die, all the mobs will start spawning as expected. Okay, there's a bunch of other functions that you can resume, but since we are running out of time, this will be it. I can show you a demo of what the game looks like if you have finished it with the UI, with the music, and with the sounds. So let's do that. I will save and exit my editor. Now I'll show you what the finished game looks like. Okay, so this is the finished game. You can even find it on the demos. And this is it. So if I press play, there's a UI, you can press the start button and you'll play it. And I'm surviving, yes. So let's just play, and then if you die, you have a game over sound, and then the mobs will start playing. This will simply make sure that the player is invisible. So if you press start again, the player will turn back to its position as expected. This is the completed game. All of the assets are there, including the font, the music, and if you want to, we'll direct you to the original documentation. So you can finish off from there, and then we can, what's it called? Yeah, from here. So I'll post the link once more. Okay, and we will show you the documentation. So, as the last part, we would like to thank you for joining us for this workshop. And to continue with the Godot learning journey, we would like to show you some of the demos that can be played. So if you ever need to, you can download some templates to export your game. And you also can have some documentation. So this is the documentation for Godot and a bunch of other stuff that was sent at the start. Now I will send it once more. There's a bunch of tutorials that you can look up and to continue with your Godot journey. So I know that this has been quite a rushed tutorial, but it's a challenge given that 2 hours is definitely not enough time to explain everything to a beginner. But that's okay. All right. So with all of these tutorials, you can definitely be able to learn some classes and some of the different types of methods that you can do. You can create a platformer, a tower defense, an action RPG. But do note that, as advice from every other game developer, is that tutorials can only get you so far. It is mainly that you have to play around with the different tools in Godot in order to know where and how you are able to play with each one of the settings. So in fact, there's many other things in Godot that we have not discussed today. And so with that, we would like to direct you to those, especially to the demo projects. So the second link is to the demo projects, right? That one has the completed Dodge the Creeps game, just in case you need any references. All right. Inside it has a masterclass of all the different demos that you can have together with all the code. So definitely do study them and you will be a better game developer. So we would like to thank you once more for joining us for our Godot workshop. We hope that you consider, you'll be excited to learn Godot, maybe consider it alongside Unity. Of course, it is definitely a game engine that's worth a try. It is new, and Godot 4.0 might be coming out, and you might be able to try some new features that will be helpful for your game development. It's definitely up to preferences as well, and something that you might find enjoyable to do. As always, keep developing games and to enjoy and to let your imagination run wild, and to enjoy game development as a whole. So we wish you luck if you're participating in the the Global Game Jam 2022, and to be able to have a pleasant time with us for the Global Game Jam. Okay, so that's all. You may take your leave, and you may also ask any questions that you have about Godot right now, and we'll try to help you as much as possible. So this marks the official end of the workshop. If you have any questions, you may stay.